In last class, we studied about the mathematical analysis of non-recursive algorithm. In that, we first studied example 1, where you studied algorithm about finding the largest element in the array or list. Now, we are studying another example here. The example is the element uniqueness problem. Here, check whether all the elements in a given array of n elements are distinct. That means when one array is given, we have to check whether each and every element is unique. That is, there is no duplicate element is available in the array. That we have to check using the algorithm. Now for that one, I have written one algorithm here that is called as UniqueElements, which will accept one array of A. Array size is n numbers. Okay. The actual use of this algorithm is to determine whether all the elements in a given array are distinct. And the input given is here called as array of A of size n. The output it will returns is true if all the elements in A are distinct. Otherwise, it will return false. How actually it will works? The algorithm works. I will explain here. Here I am using two variables I and j. I is actually pointing initially at the first array element, and j is actually pointing to the second element to the n minus 1. What I am doing actually, first I am comparing the first element of the array with the second element. If the second element is same as first element, here I am comparing here. If the second element is same as first element, I will return false. If here the if condition is false, then I go for the next element, that is j plus plus. J plus plus means it is pointing to the third element now. Here third element is actually comparing with the first element again. Then again the comparison will be done. If there is no match, again go for the next loop. And j is incremented again and pointing to the next array, that is fourth array. Like that the process continue until the j value reaches n minus 1. That means the first element of the array is matched with all the other elements. Okay, in this process, in similar way, once all the matching will be done, now the I will be incremented in the next for loop here, and the I is actually pointing to the second element of the array. Now the process started here from the third element. J value is actually pointing to the third element here, and the process starting from third element to the end. Again, this process continues up to n minus 2 elements of the array. Okay, like that this unique element works. I will explain this concept using some diagram here. Now consider this example here. Initially, the outer for loop is pointing to the first element of the array here, and the j is actually pointing to the second element, which is inside the for loop. The inner for loop is actually pointing to the starting from second element here. Here it is comparing with I and j here. That is 5 and 10 is matching. If there is no match, then the j value incremented to 16 here. Then this 16 is actually comparing with 5. If both are not matching, go to the next here. J is pointing here next. Then 76 is comparing with 5 again. There is no match. So it go to the 23, then 29, then 21, then 67. Here no matching will be done from second element to the last element, that is n-1 element. So this is called as the first loop of the outer for loop. Now in the next for loop, I value is incremented like this way. Now I is actually pointing here in the next for loop, outer for loop, and j is actually pointing somewhere here. And again the j comparison start from third element to the last element here. If there is no match found for the 10, so it is just rejected all the if condition here. Okay. Next again the I is pointing here and j start from searching here till end. The process continues. The matching of I with each element in the here array. Like that, the process, we have to compare all the elements from j I plus 1 to the end of the array. Okay. Now the next we have to analyze the algorithm. Here the next step is actually analysis of the algorithm. Okay. Now the first step is we have to identify the input size. Here, as the number of elements in the array increases, the execution time is also increases. So the input size is nothing but n here. Next, we have to identify the basic operation of the algorithm. Basic operation means the statement which will execute more number of times. Most of the times, this operation is available in the innermost for loop or loops. Okay. Now, if you see here, this equality operator will be executed more number of times because it's inside the nested for loop. Okay, so this statement will be executed more number of times. So this is the basic operation of the algorithm. That is a of I is equal to a of j, the basic operation. Next, in next step, we have to identify whether there is a worst case, best case, as well as average case scenario in this algorithm. Now, if you check it properly in the innermost loop, okay, whenever the a of I and a of j are both are equal, then it will return false. That means our algorithms will be prematurely stopped. Means there is a possibility of best case, worst case available here. Now, whenever the two elements, that is first two elements are same in the array, the first two elements are same, then within the first loop, the execution will be stopped here. So that is the best case. So we are not checking for the best case here. Now, what is the worst case of this algorithm? If you see here, whenever this first element, sorry, a of I and a of j are the last two elements of the array, it will take more number of loops here. And the second condition, second one is, if this a of I and a of j never matches, there is no comparison equality between these two. There is no duplicate value in the array. In that time also, it will take more number of loops here. So that is the worst case of the algorithm. Then in next step, we have to identify how many times this basic operation runs. In the worst case, how many times this basic operation runs, we have to identify. Actually, if you see properly here, the j value start from I plus 1 to n minus 1. That means here it is looping from I plus 1 to n minus 1. And the outer for loop start from 0 to n minus 2. Here the j will execute 0 to n minus 2 times. Totally j will execute here 0 to n minus 2 times. Okay. Now using this idea, we have to implement or apply some summation formula to calculate the worst efficiency or the order of growth of the algorithm. For that one, first find out the C worst. I am applying here two summation formula. One is for the inner for loop and another for the outer for loop. And this one indicate the basic operation of the algorithm. It is equality operator here. Now when you solve this inner for loop, it will give n minus 1. I have taken from here n minus 1 minus I plus 1, and this is the another plus 1 here, this one. This is the simplified formula I got from the inner summation formula here. Okay, when you solve it, these two ones are crossed out. We got n minus 1 minus I. If you properly see this summation formula, it's nothing but n minus I, and it's a one counter here. It's look like a series value starting from n minus 1 to 1, which can be written like this way: n minus 1. This is nothing but here actually n minus 1, n minus 2, n minus 3, n minus 4 up to 1. When you calculate this series, okay, you got n minus 1 into n divided by 2. That is nothing but half n square. Approximately it is half n square, which is belonging to theta n square. In this way we analyze the algorithm and got the order of growth here.